So this problem is a little bit long and it might get a little bit confusing, so I need you to be very patient about everything that I'm gonna do. Okay, well, we know that we're just unloading stuff from a package, and we know the downward velocity of a package of the bottom of the ramp should not be bigger than 2.5. So from there, we know that the velocity in y is going to be the maximum. Should be like at most 2.5 meters over second. Okay, so what is the largest angle? So I need to find a theta, which I don't know. You know that the height of the ramp is 1 meter and it's horizontal. Okay, so things are gonna get like big interesting here. So let's say we have like an inclined plane, like here. No, that's pretty ugly. Let me just redo it. I hate this stuff, guys. I really hate it. But well, there it is. This inclined thing. There's the height, and there is this thing. This is the angle that we need to know. This is the height, and pretty much that's everything we know for now. Okay. Next thing that we're gonna do is draw some nice axes. Okay. So whenever we find a problem in which we have a box, let me draw the box here and another color, maybe just this one. We have this box that's going down all around here. We have to draw some axes. Okay. So whenever we have this axis, this kind of problems, the best thing to do is just like not to draw the axis in the orthodox way that we did that. It was just like this way, but rather we should draw them according to the surface. Okay, so my positive, well, my y-axis is gonna be like perpendicular to the surface. This is gonna be my y-axis, and the x-axis is gonna go just in the parallel to the surface. Okay, so there we go. Now, what happens? We're gonna do as follows. Okay, let me draw it over here. Okay, so knowing that, I can just draw things in the straight way. Okay, so what are we gonna have there? We're gonna have actually the normal force that's gonna go up in the y-axis. That's gonna be the normal force, and we're gonna have the weight that's gonna go like this. Okay, so the force is gonna be on the y-axis, and the weight is gonna have like an x component and a y component. Now, whenever you see these kind of problems, the angle is going to be this one, okay? Just by rule, try to learn that it's going to be this one, okay? So, there it is. You have this angle. So, we now need to settle the equations that we're going to use. So, first thing is that the summatory of all the forces in x. What do we have in x? Well, I do have my weight. And well, I check what just like the impacts over the x-axis. And I check that let me write it here. That thing is just the sine, so I write the sine of theta, which I don't know by now, and that thing is going to move, so that thing is going to be equal to mass times acceleration, okay? So that's it. Now for y, we do the sum of all the forces, and we know that up we have like the normal force, and the weight's going to go down, so it's going to weight cosine of theta. And if it's sliding down in this axis that we just draw here, the movement in y is going to be 0, okay? So there we go. Now, what do we need to do for this thing? Well, from the first one, from x, we know that weight is sine of theta. It's going to be uh, equals to mass times acceleration. So from here, we know that mass times gravity, sine of theta, it's going to be equal to mass times acceleration. So from here, we just can tell that the mass dies, and we don't care about it. So from there, we know that the velocity, the acceleration, sorry, is going to be gravity sine of theta. Okay? So we know the acceleration, although we don't know not the angle. Okay? So now we have a very big problem. How can we solve it? Well, this is going to be a little bit confusing, and I need you to relax, sit down, and watch everything that I'm going to do now. Now, what I need to check here, first of all, is that my inclined plane is a straight triangle, okay? With this being theta and this being h, okay? I need to know the exact, I need to know, well, I know the displacement that this thing can have, and I know something else, and I know nothing else, okay? I know a velocity. So I need something that actually can relate me with some kind of distance, velocity, and acceleration without depending on time. So the formula that actually does that is going to be this one, the one I love. Okay, initial velocity squared, uh, yeah, plus, well, minus 2 times the gravity, well, acceleration. No, sorry, let me erase that for now. Acceleration, because going down on the y-axis, that's everything we know. Um, acceleration and delta x. Okay, that's everything we know for now. Now, what happens here? Actually, it's positive because it's gonna go down as the velocity is gonna increase each time. So, if we solve for this, we know that the final velocity, we do know it, we know the initial velocity is gonna be 0. We know that the 2 times the acceleration, we know the acceleration by now, so we just write gravity sine of theta. I don't know why it didn't prove itself. There it is, it died for a second, sorry. Sine of theta, delta x. Okay, so we know the final velocity, we know 2, we know the gravity, but we do not know what the angle theta is and what x is. But there's a way of knowing that. Okay, let's remember that this part over here is a straight triangle. Okay, and it's gonna move from here to here. Okay, and this is gonna be delta x. Now, from there we just can start playing with like all those trigonometric properties. We have the opposite side and we have the hypotenuse. So from there we know that the sine of theta, it's gonna be h over delta x. Okay, so now we know h is gonna be equal to delta x times the sine of theta. Okay, so from there we know h, but we don't know this stuff. But hey, look at it. This stuff also appears here. Okay, so we know that that is equal to 1. And guess what? We know everything we need. Well, we can get everything that we need to know by now. Okay, so from there, uh, yeah, that's pretty much it. Yeah, I'm just like missing something else. Okay, I know that the velocity, okay, the velocity in y, it's gonna be equal to the total velocity sine of theta. Okay, so this is the velocity I know, and this is the velocity I do not know, but I can know since it's exactly this one. Okay, so from there I know that velocity, the total velocity, it's gonna be equal to this is equal to h, sorry, to gravity h and the square root of all this stuff. Okay, now this velocity is the total velocity. I'm gonna write a little t under down there. So from there, I just have to plug it into here. Okay, so let me change colors. I don't know, a nice green would do it. So the velocity in y is gonna be equal to square root of 2gh times the sine of theta. What we need to know is theta, so we know that the sine of theta, it's going to be equal to the velocity in y over square root of 2gh. We need to solve for theta. Therefore, we get theta is the arcsine of the velocity in y over square root of 2gh. Okay, so from there, if we plug in the values, we get like the a sine of square root of 2 times 9.81 times 1 all over, this is going to be 2.5 over all this stuff, and this is going to be equal to 34.36 degrees. I know this problem can be very confusing, but this is the best way to solve it. Okay?